Hello and welcome. My name is Base. This time, I'm going to be doing something quite differently from what I did before. I'm going to walk through an AI predicted paper. And this is for the upcoming paper, June 2025, for IAL P4 syllabus. So I took all the past papers available from the 2020 October with the mark schemes, and some examiner reports were available. And then I put them all together in one of the smartest AI model called Gemini 2.5 Pro. So as you can see from the graph, I think this model is the best one to just do what I did here. As for my channel, I'm going to keep the same theme. I'm going to blind solve my own paper here, and then I'm going to mark the paper later on. And this is by no means any guarantee of any kind that the real paper will come up close to this. I just told you how I came up with this. You will see how accurate it is in time. So are you ready? Let's crack some eggs. I'm going to start the timer now. Okay, let's go. Number one. Okay, so this is binomial expansion. All right, so number one. Find the first four terms in ascending powers of x of the binomial expansion of that. So we have 8 minus 3x. First thing, you need to make the first term become 1 first. So we have, if we have to pull 8 out, we get 1 minus 3 over 8x here. And then all to the power of minus 1/3, like that. Now don't forget, when you do that, you got to power 8 by minus 1/3 as well. And the actual binomial expansion will go to these brackets. Okay, the things in those brackets. All right. Now, 8 to the power of minus 1/3 is 1 over 8 to the power of 1/3, which is 1 over cube root of 8, which is 1 over 2, right? That's 1 over 2 there. You can just try plug that into the calculator. Then this one will be, now we do binomial expansion. It's just 1 plus, following the formula, n, which is minus 1/3, x, which is the second term there, the whole thing, don't forget, plus n times n minus 1 now, divided by 2 factorial, and the second term to the power of 2. Now we expand to the fourth term. We need some more space here. And then we plus minus 1/3 minus 4 over 3. And then I think I'm going to need another line here instead. Okay, so minus 1/3 minus 1/3 minus 1 minus 1/3 minus 2, and then minus 3 over 8x to the power of 3, all divided by 3 factorial, and then we end there. Okay, just gonna simplify everything. So we have a half outside, and then this first term is still 1. 3 cancel with 3 here, and negative 2, there are 2 negatives there, so this is 1 over 8x plus, okay, what about this one? This is minus 1 over 3, this is minus 4 over 3. We have 2 negatives here and another 2 here, so this term will be a positive. And then we have 2 from the 2 3's from here, so cancel with those. So this is just minus 1 times minus 4. So it's just 4 divided by 2, so I get 2. And then 8 to the power of 2 here is 64, so it's 1 over 32. Just doing mental math there, if you don't mind. And then, what about this one? Okay, so we have 3 negatives here and 3 from here. So those will cancel to a positive sign. So we get, well, just for safety here, I'm just going to use a calculator actually this time. Okay, so let me go to the normal mode. Okay, so what was it? Minus 1/3, so it's 1/3 times 4/3 times, what's the next one? 7/3. Okay, yeah, 7 over 3, is it? 6, yeah, 7. And then times, what's that? 3 to the 3 divided by 8 to the 3. Okay, and then or divided by, just do divide there, 3 factorial is 6. There you go. Plus 7 over 768. 7 over 768, yeah? Okay. X cubed. You know what? I'm just gonna also check the third term there. Okay. Some of you may think, okay, what's the point of doing mental math if you want to use a calculator to check anyway? You know, just personal satisfaction, you know. Anyway, so and divide by 2. There you go, I got it. Okay. So here we go. And then, yeah, we got it. Oh, not yet. We got to expand everything in. So that's 1 over 16 x plus 1 over 64 x squared plus, what is that? 7 over 768 times 2, yeah, 1536 x cubed. Okay, here we go. That's the first question, first part of the first question. Okay, now B, we're gonna state the range of values of x for which this expansion is valid. Now this is important. You must know that for this expansion to be valid, the second term, yeah, the second term, the modulus of the second term must be less than 1. Okay, so we take, you don't need to take the sign because it's the same meaning here. If you put or don't put a minus sign in front of 3 over 8 here, will just result in the same range, yeah? So this is the modulus of that less than 1. Okay, or we can say that this is the modulus of x less than 8 over 3. Same thing, right? Same thing. And we can also say that that is the same as that. Yeah? Just that. To be valid. Yeah? All right. C, use your expansion from part A with x equals 1/3 to find a rational approximation of cube root 7. Okay, so this is classic. You need to nail this if this comes up, right? So the thing is, you need to substitute into two parts. You need to substitute into the actual expression there, which is this. So we're gonna substitute that, minus 3 times 1 over 3, yeah, to the power of minus 1/3. Okay, that is just the actual expression there. But then, don't you remember this? When we did the binomial expansion, this is an approximate. This can be approximated to this whole expansion. This whole expansion here. Oh, that shouldn't be a bracket here. Okay. Right? So that's going to be 1 over 2 plus 1 over 16 and then times the x there, which is 1/3, plus 1 over 64 times the 1/3 squared, and then the other one, just squeezing here, hang on, and then the other one plus 7 over 1536 times 1/3 cubed. You simplify both sides separately, don't move anything across the side, right? So here we have a 7 in the brackets, but then the power of minus 1/3 will make it become 1 over cube root 1/3. Sorry, cube root 1 over 7, 1 over cube root 7, just like that, right? Because it's a negative power there. This is still approximated to the whole thing on the right side, which can be then calculated by a super calculator here. So that's 1 over 2 plus 1 over 48, and then plus, what is that? 1 over, I'm just going to do 16 times, because that is just 1 anyway, and that's 9 there on the bottom, plus 7 over 1536 times, so that's going to be 3 to the 3, which is 27. Okay, that's a huge fraction there. So I'm just going to write down first 21679 divided by 41472. Okay, so that's our guy. But it wants cube root 7, so therefore cube root 7 is going to be approximated to flip the fraction there. And I hope that is already simplified. Yeah, and that's done. That's the fraction. It kind of like the approximation, an exact number to the approximation, because you don't want to make it decimal places there. Okay, and that's it. So as you can see, this is this question is inspired by the January 2024. All right. Okay. Next question, number 2. A function f(x) is defined as that. Show that f(x) can be written in the form of that. So this is partial fractions, right? Okay. Yep. All right. So for partial fraction, when you see the factorized denominator of the left-hand side, which is this whole guy down here, you know that you need to multiply across every term. So when you do that to the a, the b, and the c term on the right side, I mean, we're going to equate this first, right? If you can imagine, we will equate 5x squared plus 7x plus 5, and then all over those two brackets, and then we're going to have equal a over x plus 1, and so on until the c term. But if you imagine we multiply out by the denominator, yeah? So for the a term, the x plus 1 will be cancelled with one of the x plus 1 squares there. Okay, so we have x plus 1 left, and then another 2x plus 1 for that term. For the b term, because it's already got x plus 1 squared down there, so the square term there will cancel. We only have this left. And for the c term, likewise, because we are cancelling the 2x minus 1, so we're going to have left x plus 1 squared here. Okay? And then, well, we just substitute separately the critical values, each of the critical values from these brackets here. For example, if we can see that here, it's x equals minus 1, so we're going to do x equals minus 1 here. Okay? We sub the left-hand side, so that's 5. I'm just going to write everything down here, like that. But on the right side, any term with this bracket will go to 0. So that goes to 0, because when you sub minus 1 in there, it goes to 0. This one goes to 0. So we have the b term left, like that. And now we can solve for b. So this side right here is 5, minus 7 is minus 2, minus 2 plus 5 is 3. So this is 3 equals minus 2 minus 1 is minus 3, minus 3b. So b equals minus 1. Okay? Let's do 1/2. X equals 1/2. So that's going to be 1/2 squared plus 7 1/2 plus 5 equals, so the a and the b terms go away, so we have c 1/2 plus 1 squared. So what is that? 5 over 4, I'm just going to use a calculator. So 5 over 4, what was it? Plus 7 over 2, right? Wait, that's not a plus. Yeah. And then plus 5. And then we're going to divide all that by 1 over 2 plus, it's 1 over 2 plus 1 squared, so that's 1.5 squared, right? So I'm just going to do 1.5 squared here. Yeah, so that's c equals 13 over 3. Let me check with a sip of a coffee. Okay, that should be fine. And then lastly, we are out of critical values now. We can just sub x to be anything. The easiest way is to be 0, because if you have a lot of terms on the left side, well, if you sub x as 0, that's convenient, so we're going to do that. Sub x equals 0, we get 5 alone on the left side. And then the a term will have 1 here and minus 1 here, right? If you sub x equals 0, so you're going to have minus a the b term will also be minus b, and the c term will be c plus c. Here we will get a, right? So a equals minus b plus c minus 5, which is equal to, b is minus 1, so minus b is 1, c is 13 over 3, and then minus 5, all right? So 1 plus 13 over 3 minus 5. Okay, so it's a third. Not that bad. So a is a third. Now we can write the expression in, the partial fractions form. So it's 1 over 3x plus 1 plus b is minus 1, so it's just minus 1 over x plus 1 squared, right? And then c is that, so it's 13 over 3 2x minus 1, like that. Okay, so that's my partial fractions there for the part A. Part B, hence find integral of fx, right? Classic, so when they ask you to do partial fraction, normally that's what happens next. You need to integrate that. Okay, so we're going to integrate the whole lot of fx. I'm just going to write fx here, okay? So integrating the first term, well, it's just, you get a ln there, ln. So that's just 1 over 3 ln absolute x plus 1. You see, I don't expand 3 into the brackets. We don't do that. We shouldn't do that because sometimes it's tricky in terms of the bounds and everything. Like, you should make the expression term most simplified. And by that I mean, if you have any constant term in front, you should just take it out like that. Don't multiply 3 into this, right? Okay? And then for the next one, it's not a ln. It's just a normal power rule for integration. So it's just, now here is x plus 1 to the power of negative 2, right? So you're going to have to, wait. So that is just x plus 1 to the negative 1 divided by a negative 1, so you get a negative there. And because it's already a negative, so you actually get a positive, okay? All right, so that's fine. So I'm just going to write 1 over x plus 1, yeah? Okay, and the last term is still a ln, so plus. Again, don't do anything with a constant, would be more convenient. And then the ln of 2x minus 1. Now don't forget, we have a 2x minus 1 here, so actually if you recall, we need to do a reverse chain rule, because if the argument of the ln is not just x, you need to do the chain rule, which is differentiate that. So differentiate 2x minus 1, we get a 2, and then divide by 2. This is called a reverse chain rule. Don't forget. Okay, so that would be, divide by 6 instead of 3 there. So I get 6 here. Well, actually, I mean, implicitly, it's a reverse chain rule here also, but I didn't say it because I saw that differentiate x plus 1 is 1 anyway, so that's fine. Now, if we simplify this whole thing, we get, well, should we do that? I mean, yeah, we can. Well, maybe we shouldn't, because, I mean, you could try simplify the 2 log terms there, but they don't have the same coefficients here. So maybe not, because if you want to merge them, you need to make this, you need to pull the power to the argument first before you can merge them, and that makes it not that simplified, I would say. So I'm going to keep the answer like this, guys. All right? And plus c, don't forget. Yeah. Okay. Next question, number 3. All right? A curve C has equation that find an expression for dy by dx in terms of x and y. All right, implicit differentiation. Okay? This is inspired by January 2022. All right. And EI here means examiner report insight on implicit differentiation involving exponential terms and product rules. So it came up with this because in the examiner report, students make mistake on that, right? So well, the model thought that, well, it should be tested again or something. Yeah. Okay, let's do it. Part A. Implicit, of course. So we're going to differentiate respect to x term by term. So differentiating x squared, we get 2x, right? No chain rule there. Okay, now here's the product rule, right? The 2x y squared. So I'm going to separate 2x from the y squared. So u dv plus v du. So u is 2x, so u dv is differentiating y squared. So we get 2y, yeah, and dy by dx. This is u dv, all right? And then v, which is the second term, y squared du, you differentiate 2x, you get 2, so it's just 2y squared, yeah? Okay, v du, so v is y squared, du is 2. Okay, and now differentiating e to the y is just e to the y, but we need to do chain rule. If it's a y, then we just multiply dy by dx. Differentiating 5 on the right hand side becomes 0. Okay, so that's just everything. Okay, so we need to simplify this whole lot, right? Well, you can just expand everything. I mean, it's kind of already expanded here, so we're just gonna write 2x plus 2y squared here. I'm gonna put the dy by dx terms to the right side, so we have e to the y dy by dx, and then the other one is the 4xy here, but it's a minus. Okay, like that. Yeah. All right, so let me check if everything is fine. I didn't make any mistake there. Yeah. So dy by dx as a subject would be 2x plus 2y squared divided by e to the y minus 4xy. That's it. I don't think we can simplify anything further. I mean, you can pull 2 out, but that's no point because it doesn't simplify anything. And that would be the answer there. Let me check again. Yeah, I think I'm happy with that. All right. So then now you need to do B, which is to find the equation of normal. All right, at point 2, 0. This is classic, right? It asks you to do implicit differentiation and do something with it. Now we're going to use it to find the gradient. Now the gradient of tangent first, which is dy by dx here, at x equals 2 and y equals 0 would be equal to 2 times 2 plus 2 times 0 squared divided by e to the 0 minus 4 times 2 times 0. So basically, the denominator here is 1 because e to the 0 is 1, all right? And then the numerator, 4 plus 0, which is 4, so this whole thing is 4. Okay. Yep. So that means the gradient of the normal is equal to minus 1 over 4. Just flip the fraction and put a minus sign. And then we do y minus y1 equals mx minus x1 to find the gradient of the linear equation there. Sorry, to find the equation of the linear, function. Okay, y minus y1 is the same point, 0 there, equals m minus 1/4 x minus x1, 2. And then we need to make everything integers, ax plus by plus c. Okay, so we're going to multiply 4 across. We have 4y here. Okay. And then on the other side, we have minus x plus 2 because 4 disappears now. Okay. So we have x plus 4y minus 2 equals 0. So that's the answer there. All right, that's done. That's not so bad, right? I mean, let's see. I mean, the hard question might be waiting down the list. Okay, question 4. Line L1 has equation that, okay, this is vector equation. Point A has coordinates that. Find the coordinates of point F on L1. such that AF is perpendicular to L1. Now, normally it will start off with some, some easy vector questions, but this one, okay? If you don't know how to do this kind of question, you need to learn, because I have seen it come up very, very often. I'm just stressing it now, right? So every time there is a point on the line, it says there is a point F here on the line, and you don't know where that is yet. Yeah, actually it asks you to find the coordinates of that point. Whenever you see this, you can say that point F, or the vector position vector of OF, which is actually what we want here, the coordinates of F will be the same as OF here, is, you can write OF as an unknown like this. So if you merge the two column vectors there from the R, you get this, right? So there's 1 minus 2 lambda, and then minus 3 plus 2 lambda. You can already do this, where lambda is some value, which you don't know yet, and actually you probably have to find it. In order to get F, you need to find the lambda for F. So you see, if you have a good concept of understanding of vectors in P4 here, you know that lambda can be anything. It's like a variable. You compare it to a linear function. It's like the variable x that can change. So if you change a lambda, the R will change. Now we need to find the lambda for F first. Okay? And that's point F. So AF is perpendicular to L1. So we can find AF now. AF would just be OF minus OA. And that is just 2 plus lambda, 1 minus 2 lambda, minus 3 plus 2 lambda. Just checking if I didn't copy anything incorrectly there. And then minus OA, well, we already know A there is given, so this is not hard. There you go. So AF will be 2 plus lambda minus 5, this is minus 3 plus lambda. 1 minus 2 lambda minus 5, so that's 6 minus 2 lambda. Yeah. Minus 3 minus 6 plus 2 lambda here. Right? That is AF. Now they're saying that AF is perpendicular to L1. Well, for the line is not a vector. So when you do a dot product, and you should know that you are doing a dot product here, because they are perpendicular, so you do dot product equals 0. So when you're gonna dot product with a line, you don't take the whole thing. You only take what's called the direction vector, which is just the little guy after lambda. So it's 1 minus 2, 2 there. You dot product AF with the 1 minus 2, 2, and not the whole thing. Yeah, I'm stressing it, because I have seen this common mistake, with my students. You dot product that, and you equate to 0. Alright? So, of course, it's minus 3 plus lambda, 6 minus 2 lambda, minus 6 plus 2 lambda. Dot product with that again equals 0. And of course, dot product is just multiply correspondingly for each component. So it's just minus 3 plus lambda times 1, so that's minus 3 plus lambda. Minus 2 times 6 minus 2 lambda is going to be minus 12 plus 4 lambda. I'm just expanding everything already. And then 2 times that is minus 12 plus 4 lambda equals 0. Okay? So we are having what? Minus 12 minus 12 minus 24. So this is 9 lambda minus 27. That's a nice number. So lambda will be equals to 3. Yeah? Nice number. Okay, and let me check everything. Yep, I'm happy with that. So lambda is 3. So that means we can find the coordinates of F. So that means OF or F. F will be the coordinates. Well, yeah, we can just use this, right? Just substitute now lambda into that. So lambda being 3, the top one will be 5. And the y coordinate will be 1 minus 6, which is minus 5. oops, and then minus 3 plus 6 will be plus 3. Yeah. Okay. That's it for part A. Part B. Hence find the shortest distance from A to L1. Now, let's draw. So when it says shortest distance here, usually you need to draw out, visualize, right? So we have line L1. Usually, it doesn't have to be about the shortest distance. It can be about an angle. It can be about area, or anything. Usually you should draw, right? L1. And then we have a point F, remember? And then FA is perpendicular. And A has a coordinate somewhere outside the line because F is on the line, so A should not be on the line. So let's say A is here. And then we also have, wait, what? AF is perpendicular to L1. Hence find the shortest distance from A to L1. Wait, that should be AF, right? That should be hard. Okay, could have made it harder there. Yeah, let me just check again. Okay, such that AF is perpendicular, yeah, to L1. Shortest distance from A to L1 should be AF. All right. So AF, we just have to find AF, where lambda is still equal 3, right? Because that is for the vector AF there. So AF is just, here we plug lambda equals 3 in here. So the first one is 0. So I write 0 squared plus. And then the second one is also 0. Wait, what? That doesn't make sense now. Everything is 0 here. Okay, that's spooky. Interesting. I'm just checking everything again, basically, because of course, AI can make mistakes, and I didn't verify the question before I walk through this. So it might just have made a mistake there in creating the question, which I am sorry about this, but let's just check anyway. One plus 5 is 6. 3 minus 3 minus 3 is minus 6 plus 2 lambda. So we get lambda to be 3. That's kind of fine. Yeah, so A is on the line. Is A on the line? Let's see, if I plug A equals the R up there, if it's on the line, then this doesn't make any sense. So I'm checking if A is on the line. So if I put 5 equals 2 plus lambda, so that makes lambda equal 3. That makes lambda equal 3. And if I put lambda equal 3, the y coordinate would be minus 5. And the z coordinate would be 3. So basically, A is the same as point F. Right. Yeah. So A is the same as F. I just realized this. I didn't see that. So the shortest distance is 0. I'm just going to play along with it, right? But I'm sorry about this mistake here. But, well, if this were to come up, this is how I would answer, because shortest distance is 0. It doesn't make sense to ask that, but there you go there. Well, let's see the mark scheme, yeah? I also made it create the mark scheme as well. Okay. Okay, number 5. A curve C is defined by the parametric equation. I hope there's no mistake in this one. Find the value of dy by dx. Okay, that's typical. Dy by dx is dy by dt divided by dx by dt. So dy by dx, you're going to have to differentiate dt cos t there, and that is a product rule. So t u dv, so u dv is differentiating cos t. We get a minus sign t, so I put a minus in front there. U dv plus v, which is cos t, and du is just differentiating t. So it's just cos t here. That's dy by dt. And dx by dt would be differentiating t squared would be 2t. Differentiating sine would be a cos t there. That's it. And then when t equals pi over 2, so dy by dx will be equal to, we just substitute pi over 2 in the function, so I get a minus pi over 2 here first. Sine pi over 2 is 1, right? Yeah, sine pi over 2 is 1. But cos pi over 2 is 0, so I get just minus pi over 2 there on top. And this is 2 times pi over 2, so that becomes pi minus cos pi over 2. Cos pi over 2 again is 0, so that's it. Yeah? Alright, so that is minus 1 over 2. Just the pi's cancel there. That's done. Part B. Find the equation of normal to C at the point where t equals pi over 2. Right, so we already got the tangent here. So the gradient of the normal is just flipping the fraction and put the minus sign. Similar thing again here. And then we do y minus y1 equals mx minus x1. We probably have to turn the t into the x and the y first, right? So when t equals pi over 2, the x will be equal to, so x is t squared minus sine t. T squared is pi over 4. Yeah? No, it's pi squared over 4. Almost. Because t is pi over 2. Sine pi over 2 is 1. So that's just x squared over 4 minus 1. This is not going to look so nice. And then y would be equal to t cos t. So pi over 2 cos pi over 2. Cos pi over 2 is 0, right? So that is just 0 there. Then we put everything in. So y minus 0 equals x, which is 2 there, we just got. And x minus pi squared over 4 minus 1 is plus 1 there. Okay, just plugging everything in. And we need to put it as mx plus c. That's fine. So we're going to do y equals 2x minus pi squared over 2 plus 2. Okay, now if we want to simplify, yeah, I can do also 2x and then putting this whole thing into the same fraction, right? So we have plus. So I'm going to do 4 minus pi squared over 4 over 2, sorry. So you just make the denominator the same and just merge them into the same fraction like that. Yeah, and play around with the sign. So to make it nicer, I don't have to write the minus sign in front of everything. I just put the minus pi squared to the other side. And that is done. Not so nice there, but okay, I'll go with that. Number 6. A. Use the substitution. This might be interesting. Okay. So we're going to integrate this by substitution. Okay. So in the first step, we need to differentiate the substituted expression respect to the previous variable, which is x. So du by dx is just e to the x. That means dx is du over e to the x. So from what is originally asked to integrate, it's going to turn to e to the 2x over, well, we are subbing u equals x to the e to the x plus 1. So that's going to turn to u. And then dx will be this guy, right? du over e to the x. Not so bad. Now, e to the x will sort of, simplify with e to the 2x. Because you would have e to the 2x minus x, right? Don't forget, you can use a law of indices here to simplify that. Yeah? So that would be e to the x there. But e to the x is known to be u minus 1, right? If you look at the original substitution there, if we put 1 to the other side, we get e to the x. So that will be integral of u minus 1 over u du, if you do the cancellation there. So again, e to the 2x divided by e to the x, you get e to the x, and then e to the x is this. So that's why I put it here, u being the same here. All right. And now this is just normal power rule, don't forget. It's just integral 1 minus 1 over u. So we can do a split integration there using the distributive property of integration. So integrating 1, we get u. Integrating 1 over u, we get a minus ln u here. Okay, plus c. And don't forget to turn everything back to the original expression, because people might forget that. Well, that's probably a fair thing to forget, because you forget that when it asks you to integrate respect to dx, the answer should be in terms of x. Yeah. So u is, again, what was it? E to the x plus 1 minus ln e to the x plus 1. Well, e to the x plus 1 is greater than 0 anyway, so I don't need a modulus sign there. So just that. Now, we can't simplify this because it's not like we can split the ln into ln ex plus ln there. No, that would be wrong. So I'm just going to keep everything like this with the c. So e to the x, and maybe order the degree of variable there. The constant goes to the end. But you see, 1 and c here are the same thing. They are constant. So you can just merge everything and say this is, let's say, a k or something. Or c, that's fine. A k or c or a d or any letter you like, but not x. Right? Now I merge c and 1 together. So that's the answer there. All right? Not too bad. Okay. Number 7. I'm at 41. The rate of increase of a population P of insects at time t years, where t greater than 1, is modeled by the differential equation. Show that the general solution to this differential equation can be written as that. Okay, so we're gonna do a differential equation. So that's just integration by separation of variable, right? So we're gonna separate. This is not so bad. It's 2p plus 4 dp on the left side, and I'm just gonna pull dt up here. Okay. Wait, there's also 1 over t here. Sorry. Yeah. Is that right? Okay. So yeah, and then we integrate. So integrate. So on the left side we get 2p squared over 2, so that's just p squared plus 4p equals, integrating k over t, that's just k ln t. Yeah, where t greater than 1. Okay, and plus c. So we don't know k, we don't know t, sorry, we don't know c, we need to find both. Now, okay, so it tells you also when t equals 1, p equals 2, when t equals e, p equals 4. So we're going to use both. When t equals 1, p equals 2, so it's 4, 2 squared is 4, plus 2 times 4 is 8, equals k ln 1 plus c. So ln 1 goes away, becomes 0, so that gives us c equals 12. Yeah? And we're going to use that c equals 12 on the other one. So when t equals e, we have p equals 4, so that's 16 plus 4 times 4 is 16 equals k ln e plus 12. Yeah? So ln e is 1, so this is 32. Ln e is 1, so that's just k plus 12, so k is 20. This question is also typical. It gives you two conditions for you to work out both constants. And you need to know how to do that, yeah? So now we got both terms, so we write down p squared plus 4p equals 20 ln t plus 12. Yeah, we got the expression p squared plus 4p equals a ln t plus b. Everything is fine, so answer, there you go. Find the particular solution for p squared plus 4p in terms of t. Oh, I think I already did that. Okay. Yeah, sorry. So A showed that the general solution. Oh, sorry. This line has to be with the question B. All right. So I think I already did the first part and the second part together. So the first part is here. And then, you know, let me put that as A and B because it wants A and B there. Yeah, and then we have A and B. That's fine. So A and B, and this is B, and this is A. So A and A here. Okay. So this is part B. Not so bad, right? I don't know why there's so many marks there. Okay, I'm wondering. Yeah, that's too many marks to give for this. Could have been harder, right, guys? I mean, look, the question could have asked you to, you know, find the expression of p in terms of t or something. I mean, I could do that. I mean, okay, I'm improvising here. So if I want to make this question harder, because I didn't try to make it harder after the AI gave me the output, I just like put everything into the template and then just try my best to not see anything because I wanted to keep that for the walkthrough. But here, if I want to make it harder according to my version, then I would want, yeah, just do an asterisk there. I would want p in terms of t. Yeah, and how would you do that? Just think about it. How would you do that? Okay, think about it right now. How would you make p in terms of t? Go ahead, pause the video and think. Yeah? Time's up. You would have to complete square on the left side because this is quadratic on the left side. So let's do that. P squared plus 4p plus 4 minus 4. Yeah, that's just everything written again. And then you would have p plus 2 squared. I put 4 on the other side, I get 20 ln t plus 16. And then now you can square root both sides, right? Yeah? So you would get p plus 2 equals that to the power of a half. Right? Yeah. And you can't put a minus here because, okay, some of you might wonder, okay, is it possible to get plus or minus there when you square root both sides? Well, in this case, think about it. Population of insects cannot be 0, cannot be less than 0, right? So if you put a minus here, this term is always a positive anyway because it's a square root, right? So you can't have negative. So I'm just not going to put negative there. And that is it. P equals, it's not going to be that nice. I mean, but if that's what they asked, then you can do that. You could pull 4 out from the expression there. Yeah, so it could also be 2, and then in the square root, 5 ln t plus 4 here, minus 2. Could also be that. But anyway, that's p in terms of t, if the question happens to want it. Okay, I'm just going to keep my answer at this anyway, because we need to mark this paper later on. Number 8, proof. Prove by contradiction that if x is an irrational number, then square root x is also an irrational number. Okay, so we're gonna assume that if x is an irrational number, then root x is a rational. So we just put the negation at the second part of the sentence. All right, so the second part is saying root x is an irrational, so we negate that, we have a rational instead. Okay, so we're gonna start with the rational definition because we assume that root x is a rational, so I'm just gonna put that. Root x equals a over b, where a and b are integers in their lowest terms. Yeah, that is very important because when you have a rational number, you can write it in a fraction, and you have to like make sure that after you simplify everything, it cannot be simplified again, right? So for example, if I have a fraction 6 over 8, this is a rational because you can make it, okay, this is 3 over 4. So 3 over 4 is the final form that you should judge whether this is a rational or not. Okay, so that's a rational. But what if you have this? Root 3 over root 3. Sorry. I mean 3 root 3 over 3. You can still simplify this, so you cannot judge now whether this is a rational, because anyone would say, okay, this is kind of like, I mean, you can simplify it, yeah, but it's not rational here because after you simplify it, it's root 3. So this is irrational instead. But in the definition here, when you have a over b, after you simplified everything, it cannot be simplified again. Okay? So we're going to keep that as our root x definition there. So what to do after this? Well, we need to square to make x, right? So if we square both sides, we get x and a squared over b squared like that. Yeah? So, okay. So x is an integer, right? Because it's a rational number. Sorry, x is an irrational number. Okay. So if x is an irrational number, right? That means if x is an irrational number, we can put x as equal to square root k, where k is a prime number. How about that? Okay, so if you don't know what to do with, you know, something of an irrational number, you can just do that. And then what to do with this? I need to think a bit. Let me just sip a coffee. This is not usual. Okay, 6 marks. So I'm just going to do x squared equals k, where k is a prime number, which is an integer. And then from here we have x squared equals a to the 4 over b to the 4. Okay, so that is, if we equate the two, we have a to the 4 over b to the 4 equals k. All of these are integers, right? K is a prime number, so it's an integer. A to the 4 is a prime number. Sorry, it's an integer. Now, we have a to the 4 equals k, b to the 4. Right. What to do with that? Okay. So a to the 4 is a multiple of b to the 4. Of b to the 4. Somehow it needs to contradict this. But we don't know if a to the 4 is a multiple of b to the 4, then a would be a multiple of b. We can't be so sure about that. Yeah. I'm gonna skip this one first, guys. Sorry about that. I'm gonna come back to that later if I have time. I'm gonna have to do question 9 first. Sorry about this. Figure 1 shows a sketch of the curve C with parametric equations. Those two. Region R bounded by C and the x-axis, so that's just the area. It should be the area inside the curve there. Show that the volume of the solid form when I is rotated 2 pi radians about the x-axis is given by that. Okay, yeah. So we're just going to do parametric integration. So integral y dx. And this is from 0 to 1, presumably. So if we put pi, t equals pi over 2, just to see where that goes, like the x-intercept on the right there. If t equals pi over 2, if you sub that into the y, yeah, you get 0. You get 0. If you sub 0, you get 0. So that confirms that 0 and pi over 2 for the domain of t, of course, will give you the x-intercept. But we need to sub pi over 2 into the x. So sine of pi over 2 becomes 1. Yeah, so x is 1. So this is from 0 to 1 actually. Will be equal to, we change that to the bounds of t. So that is 0 to pi over 2. Y and dx by dt, dt. Alright. And we sub the parametric form in there. So y is sine 2t. Dx by dt, differentiating x respect to t, we get cos t. And that's it. dt. Not so bad here. Why is there a sine squared there? Why is there a sine squared? I disagree with that. Okay. Yeah, okay, there's a pi here. Alright, but... Oh, this is volume of solid form. Okay, this has to be a y squared. Okay, sorry about that. Okay, I'm just going to put everything in there. So this is y squared, so I just put a square here. That's it, right? Yeah, that's everything. That's everything. Okay, that's done for part A. Part B. Using the substitution u equals sine t or otherwise, find the exact value of v. Okay, so it's helping us, telling us that we should use a substitution u of sine t there. We're gonna take that advice, but I mean, this is P3 knowledge. You can use the reverse chain rule. I mean, if you want to excel in this technique, you just go check the video there that I, walk through how to do P3 integration very fast in the hard ones. So just go ahead and check out, because you can use it in this one. When you differentiate So after you go to that video, just come back here. When you differentiate sine, hang on. Sorry, I'll take that back. You can't use that. All right. So because the angles are not the same, I forgot to look at that. The angles are not the same, so you can't use that integration. Well, yeah, probably not. Probably not. Yep, I'll have to change it to this first. So sine 2t is 2 sine t cos t. And if you square that, you get 4 sine squared t cos squared t, right? Still can't use reverse chain rule there because there's too many powers there. Yeah. So it's just 4 pi and then sine squared t cos cube t. Okay, so that's the actual thing we want to integrate. Of course, using the substitution as advised, we have du by dt is cos t. So dt is du over cos t. So the volume again equals 4 pi. So we have to change the bounds later. I'm just going to not put it first. Sine squared, yeah, will be u squared, right? Because we use the u equals sine t there. So this is u squared times cos cube t times dt is du over cos t. And I can cancel one of the cos t's there. I get 4 pi u squared, and this is cos squared t du. Now, how do we do with cos squared? Well, we need to use the expression here. All right, so we know that we can use the identity. U squared is sine squared, which is 1 minus cos squared. So cos squared would be 1 minus u squared. Yeah, just that. All right, so that is our actual integration. Okay. Now let's deal with the bounds. So when t equals 0, u equals 0, when that is just x, right? This feels like the substitution brings it back to x. Okay. Yeah, that's just insane. Okay. And then t equals pi over 2. I mean, some of you might know what I'm talking about here. U equals 1. So this is just 4 pi 0 to 1 u cubed okay, and let me expand that already, right? So expand the integrand there, we get u squared minus u cubed, fourth, right, to the power of 4. And then you have u to the 3 over 3 minus u to the 5 over 5. Sub 0 to 1 in. So you get 4 pi. Well, sub 0 in, everything goes away. So we just have subbing 1 in. We have 1 over 3 minus 1 over 5. And that should be, in the brackets, you have 2 minus 5 minus 3 and 2. 2 over 15. So that's 8 over 15 pi. That's just the answer there. Okay, not too bad. And then the last one here, I guess. Number 10, is it? Yeah, last one. Student attempts that using the substitution x equals 2 sine. Student writes that. Okay, this is kind of like quite different, a different style here, but it's possible. X equals 2 sine theta. Okay. Line 2, square root. Okay, let's read the question first. A, identify the fundamental error made by the student in line 3 of their working when forming an integral in terms of theta. Okay, let's see. Okay, let's see the second line. Everything is fine. Just using the identity to change from the sign to the cos, and then take the square root. You get 2 cos theta there. And then when substituting in, it would be, yeah, x is 2 sine theta squared, and then, okay, right. Yeah, the student forgets to change from the dx to d theta. Do you see that? Somehow he just substituting dx and change it to d theta without doing the derivative first. So he would have to do dx by d theta first and rearrange, because now you can see that x squared substitute correctly, square root 4 minus x squared substituted correctly, but not the dx. Yeah. Okay, so the fundamental error here is he substituted dx as d theta while he should have done dx by d theta equals, that's 2 cos theta, right? And then subs dx equals 2 cos theta d theta instead. Yeah, that's my answer to part A. Find the correct indefinite integral. Okay, so he did most of the work for us, so we're just going to take that. That is just 2 sine theta squared, 2 cos theta here, and then d theta, as I mentioned in part A, that would be, so dx is substituted as 2 cos theta d theta, right? That's indefinite, so there's no bounds. Okay, so we're going to cancel that, cancel, and then this is 1 over 4 sine squared theta d theta. Okay, sine squared, 1 over sine squared is cosec squared. So this is 1 over 4 outside, and I prefer to bring it outside, cosec squared d theta. All right, let's pull it here. Like that. Now, in the formula sheet, right? Let's show you the formula sheet. You know that differentiating something would give you cosec squared. Yeah? So, wait, this is further math. Hang on. I went too far. Okay. So, differentiating cot gives you cosec squared. That means if you integrate cosec squared, I mean, you can move the minus sign on the other side. If you integrate cosec squared, you're going to get a minus cot. So this is minus 1 over 4, a cot theta plus c. That's it. So this is just by standard formula here. You need to be observant, right? And know that you can use the formula in differentiation to integrate. It's like just do the opposite there, because differentiation and integration are reverse operations. Yeah. Yeah, I'm just checking everything. Didn't miss anything, did I? Okay. Yeah, so that would be the answer to that. Now let's go back and do question 8. Question 8 got me here. Okay, let me sip coffee. We have 22 minutes. I mean, if you're bored, you can skip this part, but I'm just going to crack this one. I mean, because I'm in a real time condition right now, so except I'm talking. Probably you can't talk when you're in the exam room. But I'm just going to take my time to think about this. So we assume that square root x is a rational number, and that is the definition of a rational number. And then we are dealing with x, x is an irrational number here. Yeah. If it's an irrational number, a squared over b squared are not in lowest term. Okay, let's change the tone there. Right. Okay, so as x is irrational, a squared and b squared are not in their lowest terms. Well, that means you can write a that means a squared is kind of like, if you can put a factor here, k m, and b squared is k n, like that. Yeah, because if they're not in their lowest terms, then you can cut them out like that. Is that kind of okay to do though? I'm just gonna think about that. So x is an irrational a squared, and okay. Because when you now divide a squared over b squared, you can simplify using k. So the common factor between a squared and b squared is k, right? So that means if we put everything back into the x here, k equals m over n. Now m over n should be a rational. Yeah. Because when you write k times m and k times n, k is the greatest common factor. Yeah, because when you have some irrational, which is the opposite to rational, you can simplify the fraction using the greatest common factor. So when you cut that out, you get m over n. And now m over n should be in their lowest term. And that is saying x is a rational number, which it isn't. Right? I mean, I'm just playing around with it here. Okay? So, as m and n are in the lowest terms, so x is rational. So this contradicts that we said earlier that it is irrational, right? So this contradicts blah blah blah, and you know what I mean after that, because I'm not going to interfere with the next page there. So, and then we final statement. You know what I mean. I'm going to write final statement if I have the space. So final statement would be just copy paste everything, that if x is an irrational number, then root x is also an irrational number. I would write that if I had more space there. Okay? But you know what? Let me just write that. I have time. I can afford some time here, you know, just to make it proper. But I need to resize everything first. So this contradicts the assumption that x is irrational. Therefore, the original statement is right. If x is an irrational number, then root x is also an irrational number. That's just my best shot. I have never seen a proof by contradiction like this. Well, I have done a lot of proof by contradiction in irrational number, but it's just a different nuance. But this is new. Okay, by the AI there. It got me. I'm not sure if this is correct. I'm gonna find out soon here. And I'm gonna stop the timer. And let's mark the paper. Okay, here's the mark scheme for the predicted paper that I made by telling the AI to come up with it. Okay, so I'm not sure if the mark scheme has the merit about all this, but if we get the same answer, then we should be fine. Okay, looks like the first one I don't get the same answer here. Right. Okay, what's wrong with that? Okay, let's see. What? The first one doesn't seem right. Yeah. Yeah. Oh, no, it's right. Yeah, it's right. Okay. Yeah, that should be fine. I mean, I don't know about this, but wait, what? Huh? Let me check the third term here, right? Because yeah, again. So all right. So it's 1 over 3 times 4 over 3 times 7 over 3 times 3 over 8 to the power of 3, right? And then 3 factorial. Yeah, I'm right. So that's 7 over 768, but then you have the power, a fraction of 2 here multiply in, so that becomes that. So this should be right. I don't know about this 7 over, that should be wrong. Yeah, that's not right. Okay? For sure. Okay, so I think I got everything there. Yeah, this is fine. For B, for C, yeah, I'm guessing this will be affected by that too, because yeah, you see, because it uses the 3000 here. So I think I'm okay with this. Yeah. See if I substitute everything correctly. 1 over 2. Yep. I think I'm fine with all that. And then I get this fraction, so this should be right. Okay? I mean, I'm not being too kind to myself here. I'm just being critical. You know, just to make it fair, but it seems like AI got it wrong at first. So sorry about that. Okay. Of course, they always tell you that AI can make mistake, right? This is where it does here. Yeah. Look, I'm gonna check this whole substitution again. Yeah. If you can bear with me on that. Okay. 1 over 2, right? Plus 1 over 48 plus 1 over 64 times 9, yeah, plus 7 over 1536 times 27. There you go, I got the same thing. And if we flip that, we should get this. Okay, I hope that's clear. Next, question 2. All right, so that is right, that is right, that is right. Okay. Part B, yeah, ln that, and that plus C. Okay, yeah. Question 3, implicit differentiation. So just 2x plus 2y squared. Okay, everything is fine, good. All right, part B. The gradient is 4 there. As you can see, gradient of the normal is minus a quarter. And then the equation is x plus 4y minus 2 equals 0. Okay, so far so good, right? Number 4, this is vectors, so it's 5. Yeah, the f here is 5 minus 5, 3. And then this is the funny one. AF is 0. Yeah, so shortest distance is 0. All right, so it realizes that the question doesn't make sense, but okay, yeah, there you go. There. I mean, if it ever came up, then that would be what you should do. Just answer using the right concept there. Okay, this is minus a half. That's fine. And then we have, yeah, it got this expression there, so same thing. That's okay. Question 6. We have this. You see, it answers the same thing here. Oh, it doesn't have, right. But I think it should be the same. Yeah, this is fine, guys. You merge one with the C or don't merge, it should mean the same thing, right? I'm confirming here that this is not a mistake because I ignored the one there, right? I put it into a different constant because it's an unknown constant anyway. So if you do 1 and C together, it's just another different constant there, which is fine. Okay, no mistake there. Okay, and then I have everything here. This is easy peasy, right? So it's 20 and 12. Yeah, here 20 and 12. Okay, and now this one, a bit excited and keen to see this one. Assume contradiction, x is irrational and root x is rational. Okay, I got 1 mark there. And then if root x is rational, then root x is a over b, where a and b are integers, b not equal 0, simplest form. Okay, a and b are co-prime, right? And then it does x equals a squared plus b over b squared. All right. A, b are integers, so a squared, b squared are integers. Since b not equals 0, okay, therefore x equals a over b is a ratio of 2 integers with the denominator not 0, so x is rational. Wait, so I'm jumping to the part where also I found that x is a rational here, but with a different reason. With a different reason. So let's see here. States the assumption for contradict. Okay, I got 1 mark there. Express x. Yeah, I got that mark. Argues that a squared, b squared are integers and b squared not 0. I didn't quite say that, right? Conclude that x is rational based on previous steps. I'm not gonna, well, see, the most marks that I can lose is 3. These 3 marks I can lose. Because, I use a different path there. So the argument of the AI here is that when you have x equals a squared over b squared, is a ratio of 2 integers with denominator not 0, so x is rational. Oh yeah, I should have seen that. Hang on. But I did, because we assumed earlier that x was irrational. Yeah, that would have been much easier, right? The AI step here would have been much easier. So you got this to be, so when this is in lowest term, when you square them, it's also in lowest term, because a and b don't have any common factor at the start in the first place. And when you square them, they should not have any common factor either. So this is still rational then. Right? I should have seen that. Yeah, I went to a slightly different approach. I went on saying that because we assumed earlier that x is irrational, so a squared and b squared are not in their lowest terms. And then I found out later that x equals km over kn in their lowest term, so x is rational. I think I might get 1 mark here. So you see, I might get all the 3 marks because there is no alternative here. Usually the Edexcel mark schemes, they will tell you alternative, right? But okay, the worst case scenario is I lost 3 marks, right? And I'm going to be harsh to myself. But as you can see, you see how to prove that, right? Okay, so I lost 3 marks there. Probably the only 3 marks I lost, I hope. Okay, what about this? Question 9. Let's look at the answer. Question 9a. Yeah, I proved that, right? So that should be fine. Why does it have to write so long like this? Okay, this is endless. Sorry about this. Sometimes it's just self-correcting itself and it takes too long to just arrive at the conclusion here. Okay. Yeah, where k equals pi. All right. Next, part B. 8 pi over 15. Yeah, I got it. So that should be all right. Okay, number 10. Student forgot to replace d theta. Yeah. And then the final. Cot. Oh no. Oh no, I forgot. You see, I told you in the video earlier that, you know, don't forget to change, find the correct indefinite integral for that. Yeah, I forgot to change the cot theta to back to the x, right? Because we use, yeah, I forgot to do that. So, okay. Yeah, hang on. Sorry. Yeah, I should have turned cot x here into something in terms of x. So here is a cot. Yeah, so I got up to this, right? Yeah, this minus 1 over 4 cot theta here. So I got at least, hang on. Correctly defines the x term of d theta. Yeah, I did that. Wait. Is that A or B? B. Hang on. Yeah. Integrates to k cot theta. Yeah. I just lost the final marks there. Didn't substitute it correctly to the x form, x expression, which should have been that instead. Yeah. If you try work it out, follow this. You will get cot x to be square root of that over x, right? Okay, there. So that was it. So I lost 5 marks, I think. Is it? No, 4 marks out of 75. So that is that makes it 71 over 75. So the proof got me there. And so that was it. I will post the file, the solution here, that the work solution in this file here on a website. Or a Google Drive. So you just check out the description. There will be a URL link where I share everything. The predicted paper, the work solution here that I write, and the mark scheme. And it's just, so that there can be some mistakes there, as you can see, right? For the mark scheme, I think I will correct it because it made a mistake on the binomial expansion. And the general feedback for this one is, yeah, it's not too hard. It's actually not too hard. It's okay. But in some question, I would say, let's bring the paper back. Okay. So in some question, I would say, like the, let's go from the beginning. Yeah, this one is classic. It's actually an average level. It's not easy. It's not hard. It can come up often. So you gotta nail this one, all right? Number 2, this one is not a too easy partial fraction, so you gotta be careful in finding A, B, and C. Integration is fine for this one. Don't make a mistake about integrating each term there. This one, implicit, yeah, typical, but be careful when you do product rule here because the examiner reports here might, they sort of like emphasize that students make mistakes on the product group, so be careful with that. All right, this one very typical for question A, so I think this one is kind of like easier than the average. Could have been harder there, but for B it's probably just a mistake, but the mark scheme is kind of like correspondingly correct into this mistake that the distance becomes 0, so that's fine. That's just what you do there. Question 5, yeah, kind of fine, typical. This is easier than the average, I think. Well, this one maybe slightly harder than the average for substitution. No, I think this is fine. This is still easy, not that bad. This one could have been harder if it asks you to find P in terms of T, right? Yeah, and yeah, this is kind of like, so usually it would give you one condition to find just the C, but now there is a K constant as well, so you need to find K and C. Yeah, so that's why you are given 2 conditions. Sometimes they also give you the rate of change, so they might tell you also in words that the rate of change of population is something when time equals something. So you need to know that it's dp by dt, and then you sub in, you get 2 conditions, you solve K and C. Okay, so this is also fine. I mean, could have been harder if, again, what I mentioned earlier, if that is P in terms of T instead. This one is tricky, but I think is legitimate. This one is legitimate question. It's not tricky in the way that the question doesn't make sense, but okay, that's okay. That's not bad. It's a new style. I've never seen this one in any past paper, but I think it's a possible one, right? And make sure you learn the mark scheme that I showed you earlier. All right. Parametric, this one is fine. Just don't forget to change everything back to the T. All right. Oh, it asks you to integrate definitely here, so 0 to pi over 2. Yeah, I mean, if you know what I mentioned, if you know what I meant in the walkthrough, that when you use this substitution, that's exactly the same definition of x. So this is actually substituting back to the Cartesian form, which is kind of like, yeah, a bit weird. This one is okay. Yeah, I forgot to convert the cot theta back to the x because I was worried about the proof by contradiction there. So I kind of like urged myself to get this done and get back to question A. And yeah, this is also fine. So nothing particularly too hard, I would say. Overall, it's a good blend. Some questions are too easy. Some questions are kind of tricky. So I hope that this will be a useful tool, not to be like a guarantee of any kind. Full disclaimer here. It's not meant to be a guarantee of any kind that the questions will come up anywhere close to this. It could, but if the questions do come up similar to this, you have a bonus because you've seen my video here. So enjoy and good luck. I'll see you in the next video.